Hi guys, so today I'll be covering the last part of this topic, which is AC and DC distribution, right? So I'll be doing the AC interconnected. I did AC ring on the previous video. Now I'll be covering this last part, right? Again, please copy this thing and just have it with you somewhere. I have my hard copy with me here, so I won't be going back and showing this thing. So just have it copied. Now let me show you the question. There's a question, so I'm gonna read the question for you. Is example number 4 is on slide 35. ETG notes, right? It goes like this. Example 4. The figure below represents a single line diagram of a two-core AC ring distribution network. The interconnector of impedance is ZAC is equals to 0.48 plus J 0.18 ohms. The impedances of the feeders are the following. Then they gave you the resistance values. Calculate the value of the current in branches A, B, and BC of the network. Right? Cool. That's what you know for now. So let's now get to our sketch and then draw the circuit as they did. Yeah. Let me zoom in. So the circuit looks like something like this. You have that is 380, then that's bus bar A. It goes to, okay, I'm gonna pause the video and then draw the circuit. So guys, that is our circuit, right? Now this circuit is the same as the previous one. The only difference now is that you have an interconnector between A and C, and then they give you the resistance of the interconnector as 0.48 plus J 0.18. Right? Cool. So remember, the first step to AC problems is to always give them direction, and you give your currents direction assuming that your current flow from the supply all the way to the right hand side of the circuit. Then you have that, or let me say all the way to the furthest point of the circuit, right? Cool. So we have that. That's the first thing we do. What am I? Okay, I'm not missing anything. Now, step number 2, we remove the unknown or the interest branch or section. In this point, they're looking for IAB and IBC. That means that's what you're gonna remove, right? Cool. So I'm gonna remove this and just remove that, and then have it. Oh no, I'm gonna have it drawn with chain lines to remind me that I have something there, and then I have something there as well. Yeah, right. Cool. That's the first thing we do. So meaning we only have now ZAC, ZAD. Oh, troubles. Okay, let me put this down. We have ZAD, and then we have ZAC, and lastly that's ZCD. This is what we have. Right now, let me show you how. Okay, I will show you. The second step that we need to do now, we convert the Z's to Y configuration. Let me show you why we said they're in star. I'm gonna draw, this is Z, this is A, right? And then this is what is this? This is C. And then we have that, you have D there, then we have that. Now all these Z's are linked with a bus bar, a bus bar, a bus bar. So you end up with something like this. That's A, C, then D, right? So that's your three-phase star connection, not star, I mean delta connection. So we need to convert that to star. I'm gonna remind you how to do it if you forgot. Cool. So we have this. I want to make it a bit bigger. Oh, let me say, right? That's C, that's D, and that's A. So we want to go to star, meaning you're gonna have coil an impedance there, go into the middle, and then an impedance there, go into the middle, and then impedance there, go into the middle, right? You remember the Z values that were given. Your ZAC, let me switch back to it. AC was given as 0.48 plus J 0.18. I man 18. Cool. Then ZCD or DC, that's 0.36 plus J 0.16. Cool. And then your AD, you have 0.42 plus J 0.12. So you know what I'm gonna do now? I'm just gonna convert these Z's to polar and then just place them underneath. We're gonna need the polar values. Gonna put. So that's what I did, right? I just converted those rectangular values into polar values in color green, right? So the next thing we need to do now is to convert our delta connection to star. To remind you how we do it in star, I have this thing that I use. So we're now moving from delta. This is the picture. We're moving from delta to how do I copy this? Let me see if I'll copy to clipboard. Good. And then can paste it this side because I wanna work on it. Okay, we decided to go there. Sharp. We're moving from delta to y or to star, right? So what is inside these square brackets? I'm gonna read it for you. I know it's not okay. Let me read it for you. I said you divide the solution you get when you multiply, meaning this is the product, right? Sharp. You divide the product of the two ears. We will get to the ears part. You divide the product of the two ears by the sum of the total Z, meaning this thing is the solution you get when you add, right? Okay, let me do it again. That plus equals to thingy is the solution you get when you add, meaning this is the sum, right? And then you have this. Now that is simply the solution you get when you multiply. That's the product. Cool. So by the ES, this is what I mean. Remember, from delta to star, you have it like this. You have delta and you're looking for star, right? Now let's focus on, let's say we want ZA, this one. Here we're going to star, right? So we're looking for this Z. The ES to that Z is Z1 and Z3. those are the ears. These are the ears according to my unpublished textbook. Yeah, those are the ears, right? So I'm not gonna do it here. I'm just gonna somehow get here. Let's start by, okay, remember you have neutral there. Cool. Let's start with an, meaning z of, okay, z of an is equals, remember set is the product of the two ears, meaning that is zac times zad all over z total. You get it? Meaning you're first gonna have to find the z total because we're gonna use it everywhere. So let me move this. So I'm actually gonna delete. Cool. Let's find z total. Wait. Okay. Didn't we'll remove it. So z total is simply zac plus zad plus z. What else? Is AC AD plus DC. So you have 0.48 plus 0.18. 0.48 plus J 0.18 plus, now you go to AD. Your AD is 0.42, 0.12, 0.42 plus J 0.12. And then our last Z, which is ZDC, that is 0.36 and then 16. 0.36 plus J 0.16. Right? So now you're gonna add the like terms and then yeah, I'm gonna post it. So that's what I have. That's the Z, this is ZT, right? This just the rectangular, and then that is the polar. So I'm gonna remove the steps and then just keep the Z itself. Why do you keep doing this, babe? Cool. That's ZT. I'll snatch all of that. Just go put it, let's say here. Oh no. Why do we still have this? Put it up there. Cool. We're gonna need it. So I did something. Okay, so let's start with ZAN. ZA neutral is simply ZAC, remember set the 2 ears, times ZAD all over ZT. Okay, I think I might have got too close there, so I'm gonna put it right there. It's cool. Hi. Sharp. So ZAC, that's 0.15, 20.56. Yeah, 0.513, 0.513. Then angle of 20, I think that's 36. Oh, that's 56. Time is, now we have 0.437 at an angle of 15, 15.95. All over the ISO ZT. Like I think I should, because this thing, yeah. Copy. Paste it right there, right? And then we have now equal sign. I'm gonna do this thing offline. Good. So for ZAN, this is ZAN, right? Where were we? The last time you saw me, I think I was somewhere. Oh, I was here. Then I multiplied those thingies, and then I got to this point. This is simple complex math, and then I just converted this value to rectangular. This is the rectangular representation of this, right? Cool. So I'm gonna create space. Come on. I'm gonna create space there, and then just take the whole thing, put it up there. Now, I'm not gonna do everything on the video. You saw how I got ZAN. For Z, or let's say CN, is gonna be ZAC times ZDC all over Z total, right? For ZDN, is gonna be ZDC times ZDA all over Z total. And then you get your star Z's, right? So I'm just gonna pause the video, come back with the final values. Yeah. Okay, guys. For the sake of time, I see. I'm looking at ZAN on the slide. They named it ZA. They have 0,176. At an angle of 14,37. I think it has to do with just the way we round it off. So I'm not gonna calculate these things anymore. We really don't. Well, I really don't have time. So I'm just gonna take them from the slides as they are, calculate them to them. You should get something at least close, right? Cool. So yeah, pause. Good. So that's what we have, right? Yeah, these are now our z's. These are our new z's. These are our new impedance for each line, right? So now what we have to do, we have to put back our star. Okay, now we are now left with something like this. That's A, that's C, then we have N, and that's D, right? You have that. So now we have to place back, or we have to put back the z's that we just calculated, now meaning our star configuration. Now we have to put it back and into on our original circuit, and then put back the unknown branch, meaning we're gonna have, okay, let's start with DN. That's bus bar D, right? And then you have point N. I'm also gonna treat it like a bus bar as well. That's point N, right? And then you have ID coming out. It's coming out. Okay, cool. And then my god, why didn't I, let me go somewhere else. Oh, just put it down there. Cool. There. And then now we continue. Out of, here's our circuit, right? We just did this. Now out of N, we also have C in that side, CN, meaning N is also attached to bus bar C. This is bus bar C. Then you have IC coming out there. Cool. And then again, the same N bus bar is linked with distributor connected to bus bar A. Yeah, don't forget the L's. Those are our currents. Yeah, yep. Now I said we're gonna put back the unknown branches. Remember we moved A, B, and B, C. Good. So we're gonna bring them back now. We are done doing whatever that we had to do on their absence, right? That's B. Then you have IB coming out there. Then you still have your supply, supplying at A. That's still 380, nothing changed. So yeah, the resistance here is still the same as the one that they gave you. It was 0.25 plus J 0.15. It's still the same thing. AB is still AB, right? Yeah, and then BC is still the same. It's just that they just got back from the holiday, wherever they're coming from, right? Oh, we forgot the errors of our currents. Good. So now we have that. You will label them and then enter your, just include your Z values in your sketch for you not to get lost, right? Our next stop is to open the furthest distributor of the unknown, right? Remember the unknown is AB and BC. So we're gonna open the furthest, which is BC. I'm gonna open that and give it blue to remind us that we had something there. Good. Now we have that, right? Take note as I withdraw. Let's continue. Let's continue. Cool. So now that is open, right? When you have an open circuit there, meaning IC is in series with ICN, correct? I know you see it. I explained this on a previous video. So your IC is equals to ICN. That is IC the I don't have space. Oh, my PC is okay. I'm back now. Your IC is in series with ICN, and that gives you 54 negative, 54 at an angle of 43, not 34, 43, negative 43,95, right? Sharp. And okay, we are done with it. Remember that ICN is not the actual current. Yeah, it's not. It's just a temporary current. Cool. We also have IB in series with IAB. IB is in series with IAB. That gives you, I'm gonna put it below, right there. That is 42 at an angle of minus 27,13 degrees, right? So we also got that. Now I really need space. I'm gonna remove this thing here. You have it, Moss. You have it. You should. Hey, wait. Hello. Okay, I'm back. I at least I managed to make some space. So now to find IAN. IAN is approaching bus bar N, right? And then IDN is leaving, and then ICN is also leaving the point, meaning this is equal to sum of these two, right? Cool. Let's see, did we calculate DN? No, we didn't. However, your ID, your this current, oh, wait, wait. Okay, this current here is in series with IDN, correct? Meaning, your, how should I? Your IDN is equals to ID, and that is 48, comma minus 35, comma 9. I feel like I didn't explain it. Gary, you have point D there, right? And then you have point N there. We just know that current out of that point is that 48. But then we have a wire from this point to this point. It's not going anywhere, it's not splitting or changing directions, it's the same wire, right? So series connection, current here is equals to current there. And then we also have how many, okay, now we have a lot of wires coming into N. We have that's AN, then we have CN. Cool. Oxalayo. I wanted to show you that DN, this thing, our DN is equals to ID. Our IDN is equals to current ID, right? I hope now you saw it. Cool. Sharp. So now we're continuing, right? This is why we're gonna apply current Kirchhoff's current law that says IAN is equals to ID plus, okay, let me say IDN. I'm sorry, IDN plus ICN. Right, I'm not gonna substitute values. I'm gonna take this straight from the slides because I believe they did the same thing that I did. You will do it on your own, testing your knowledge. Oh. Let me pause the video. Sub. They got IAN as 101.9 something, right? So let's go back to our circuit. We have that. Now we only have one unknown, which is the open circuit, right? It's cool, it's okay, we will get to it. Now our next step is to find now the voltages. Just, I hope now you are aware that we're doing everything that we did with AC ring, right? Right after having this circuit, we're now repeating the same thing that we did with AC ring. We took advantage of the series current, and then now we have to find the voltage of each section, meaning we're now looking for we are now looking for VAN, not AN, AC. We're going for VAC, which is gonna be IAC, RAC. You agreeing? Yeah? And then we also gonna look for A, what is it? Okay, I'm sorry, it can be AC, it's AB because distributor BC has been removed. So please, I'm sorry. I'm sorry. Now our VAC, now this is gonna be IAN RAN plus ICN RCN. You're gonna multiply these two, right? And then again, I'm not gonna substitute values. I'm gonna take values from the slides. We all have the slides, but just do them and then see if very you agree with what they got. If you do not agree with what they got, but then you follow the right procedure, then you are right, and probably the memo as well. I'm not saying wrong, I'm just saying. Our VAB is 12,254 from the slides at an angle of 3,83, and then AC is 25,011 at an angle of minus 22,06, right? From there, remember, we have to find now V and V is nothing but BC, which is the difference between the top and the bottom voltage. I hope you are aware that this is the bottom and then this is the top, right? So that's VAC minus VAB. I know you did that. Let me see. We'll start with the Z. Anyway, it doesn't matter. Why do we have minus? Why do we have bottom minus top? I'm gonna repeat this thing again. You see, VAN is heading into that direction, and is going to the same direction with CN as well, right? This is counterclockwise, but then AB is going in an opposite direction. This is why you have subtraction, right? Just I want you guys to be able to see that and not cram it, but I know you saw it. Okay. So your V Thevenin, which is also your VBC, they found it as 14,982 at an angle of minus 42,97 volts. Cool. And now they found Z Thevenin is nothing but ZAB plus ZAN plus ZCN, right? And then Z they found that as 0,596 at an angle of 26,17 ohms, right? From there, you remember that from that step we go for current, which is I Thevenin, which is also known as IBC. Now remember, we now put back the branch that we cut, right? And that's gonna be V Thevenin over Z Thevenin plus the R of the branch that we just put back, which is the unknown one, that's BC, right? They must have done that. Let's go on the slide. I'm looking at the slide now, I'm saving time. Yes, they got their IBC as 15,137 at an angle of negative 68,26 amps. That's 8. Cool. Please do that and then make sure that you get to that solution. I'm sorry that now that I have to do this thing, guys, I'm like this, I'm really out of time. Cool. Now we have what is that? It's IBC. Okay, let me create space. What should I leave behind? Okay. So now that we found, remember this is I unknown, which is IBC, right? I said we put back the branch, so now we have this. Now Kirchhoff's current law, ICN is equals to IBC minus IC. I know you see it. Yes, I know you do. Okay, let me leave the bunch there. So please do calculate that, and they found that CN as, what is it? What is CN? I'm gonna pause the video. Okay, now I'm pausing this. Hey, this letter there, fella. So I Mr. Conjo. Anyway, yes, you're gonna find CN, right? So pretend that you found CN. Because I'm sorry, I'm not gonna do it. I'm really sorry. I'm sorry. So now you have ICN, right? From ICN, you have ID, you have ICN. You can find AN. AN is equals to ICN plus ID. Let me write it somewhere. AN is equals to ID plus I'm sorry, I said CN, correct? Yes, it's CN. Good. Ne? And then now you found that current, and then again applying Kirchhoff's, you have that current, you can find this one, right? That's simply IB plus IBC. Good. Let's go. IAB is equals to IB plus IBC, and then you're also gonna find that current there. Let me pause the video and then just clear the space. Nope, I'm sorry, there's no need to clear space because we are done. So we found the actual currents. Remember I said those currents which is the stairs, or yes, the stairs to the top floor, right? So now we using these formulas, you're gonna get you're gonna get the actual currents, and they're only interested in this current and the Thevenin current. So yes, please do find those. I will calculate them off the video and tell you what I found, and just make sure that yours is the same as, should I say, as mine? No, anyway, I'm just gonna come back with final values. Okay, and no, the slides were not cut short. I see. They found what they were looking. They found what they were looking for. Remember, oh, they found our their a IAB S54, S54, 322 at an angle of minus 37,69, and then they found, you already found the Thevenin, which is BC, right? So that is, I think it's 28 marks. So that's your 28 marks, guys. That's if they will ask it like this. So that's the last promised video. This is the last promised video, or the video that I promised that I was gonna record. I don't know, I think because I saw other people are struggling with interconnected, I'm not gonna do anything on interconnected except for explaining the formulas. It might reduce the pressure, understanding where formulas come from instead of just cramming them. So I don't know, I will see if I can record another video just explaining the interconnected formulas. Otherwise, that's it from me, guys, and do it.